Hi everyone. In this video, I'm going to discuss a few examples on the question involving the quadratic equations. Okay, so here is a problem about the quadratic equation. Find the possible values of m if the equation x squared minus 4mx plus 4m plus 8 equals to 0 has an equal root. So from this question, we are going to find the possible values of m. Here we may have more than one answer of m, and then it gives us the information this quadratic equation has equal roots, means that we know that the discriminant it is equals to 0. B squared minus 4ac equals to 0. So from the quadratic equation, we need to extract the value of a, b, and c, okay, by comparing it with the general form of the quadratic equation. That is the ax squared plus bx plus c. All right. Compare these two. We know that the a is equals to 1 and the value of the b will be negative 4m. That will be the coefficient of the x, and the c will be the constant. Here we have a 4m plus 8. So now I'm going to substitute those values a, b, and c into this discriminant b squared minus 4ac and equate it to 0. After that, after we solve for the value of m, then we will need to solve the equation by substitute the value of m into the equation. All right. Now, so consider the b squared minus 4ac equals to 0. B squared, here we have a 4, negative 4m squared minus 4ac. A is equals to 1, c is a 4m plus 8. This is equals to 0. So now I'm going to expand and simplify it. After I have expand, I have a 16m squared minus 16m minus 32 equals to 0. Then I'll see that these are the coefficient, the three terms here, it all can be divided by 16. I'll try to simplify it by divide all the term that is left and the right side divided by 16. Then I have m squared minus m minus 2 equals to 0. After that, try to factorize it. Factorize this equation. I got 2, 1, and in order to have a negative m, here I need to have negative sign, and this will be positive. Then I will expand back, see if I got back this. All right. Then after that, I have my m equals to 2 or m equals to negative 1. Okay, so we have two values of m. Now I'm going to substitute the value of m into the quadratic equation that is given and hence solve the equation. So the equation given here is this. This is the equation. Now substitute the m equals to 2 inside. When m equals to 2, we have the equation to become x squared minus 4. Substitute 2 into the m. I got a 4 multiplied by 2x plus 4 multiplied by 2 plus 8 equals to 0. Then I have my negative 8x plus 16 equals to 0. Then to solve this equation, again try to factorize it. I have 8 4 2. So in order to get a net 4 2 4 4, yeah, 4 4. Okay, 4 multiplied by 4 is 16, and to get a negative 8, as here the sign has to be negative and negative here. So we have x equals to 4. So this is actually satisfied what we have interpret from the question, that this equation has equal roots, because the m values is we got it from the b squared minus 4ac equals to 0. So we know that when m equals to 2, substitute into this equation, we have only one real root or two equal roots. All right. So for the next m, when the m equals to negative 1, substitute into this equation, you got a Simplify it. This is plus 4x, and then you get plus 4 equals to 0. Factorize it, and we can predict that our answer should be two repeating linear factor. So I'm going to put this as 2 to expand it. All right, you get back this, okay, the left hand side. Then we have x equals to -2. Means that when the m equals to 2, our solution is x equals to 4. When m equals to -1, solution is x equals to -2. Here is the another example on the quadratic equation. Show that the equation, this is a quadratic equation in terms of m, has no real roots. Has no real root, meaning that we need to show that the discriminant of this equation is less than 0. But since the question asks us to show, meaning that initially we do not know, we have to pretend that we do not know whether it is the discriminant is less than 0 or not. We need to show, okay? We need to prove it. So start from the writing down the quadratic equation. And we have to determine which one to be the value of A and B and the C, so that we can substitute into our discriminant later. So here we have A is a coefficient of the x squared, that is 2m squared, and the B will be 4m. The C is equals to 5. So now I'm going to prove that the b squared minus 4ac is less than 0. But the way that we prove, we cannot say that this is less than 0. We must prove that this is less than 0, meaning that initially we cannot write less than 0. We just write down b squared minus 4ac and put the value abc into this discriminant. That is b will be 4m squared minus 4ac, a will be 2m squared, and the c is 5. Okay, then we have a 16m squared minus, all right, then we have a negative of the 24m squared. Okay, so we can see that the m squared, we do, regardless what value taken by the m, if you're taking the value, square it always will produce a positive value. So a positive value multiplied by a negative value, that is negative 24, it is always less than 0. We will say that the negative 24 m squared is always less than 0. Then we need to make our conclusion. We say since the b squared minus 4ac is always less than 0, therefore we say that the equation has no real root. This is how we prove. Okay, we again I stress on initially we don't say b squared minus 4ac less than 0, because the question is asked us to show. So we need to start from the b squared minus 4ac and then substitute the value of a, b, and c into the discriminant here to prove that this is less than 0. If this is always less than 0, then only we can make the conclusion the equation has no real roots. All right, so we say that we have shown that the equation has no real root. And bear in mind that when you want to extract the value of a, b, c, you need to make sure that your equation must be in general form. All right, general form means that the right hand side has to be 0 and the left hand side has to be arranged in such a way that the x squared term will be the leading term, and followed by the x term, and followed by constant. All right, thank you. Now, here is another example on the using the discriminant to solve the problems of a quadratic equation. So here is the question: express t in terms of u and v. If the equation, this is a quadratic equation, has equal root. So this question already told us that this equation has equal root, meaning that its discriminant is always equals to 0. Okay, then we need to express t in terms of u and v, meaning that later on your answer should be t as a subject, and at the right hand side it will be in terms of u and the v. Okay, so start from copying down the equation. So we can see that the equation given is not yet in the general form. So it's hardly to extract the value of a, b, and the c out from the equation. We need to arrange it first. Okay, the x squared term will be the leading term. And I'm trying to expand this. I will have a 4tx plus 4t plus a 4ux minus 2v equals to 0. So the second term should be the x term. So the x term, there are two x term. I'm going to collect them together and factor out the x. I have a 4t plus 4u. Factor out the x, it will be like this. And then after that, I have my constant term, that is 4t minus 2v. So here again, we're going to put it together. 4t minus 2v, this is our constant, that is the c. So our a will be the t, the b will be here, the coefficient of the x, that is 4t plus 4u, and the constant is 4t minus 2v. So here now you can just write down what is the value of a, and the b will be 4t plus 4u. C will be 4t minus 2v. So here now I'm going to put all those value a, b, and c into this statement, that is b squared minus 4ac equals to 0. So b will be 4t plus 4u square it minus 4ac, a will be t, all right, and the c is a 4t minus 2v equals to 0. So now you can have a one equation involve the t, u, and the v. So later on we find ways to simplify until a stage that the t in terms of u and v. Here we expand and simplify first. After the expanding, I got this and then collect the like terms together. So you can see that the 16t squared minus 16t squared is cancel off each other. And now I'm going to to write t in terms of u. In order to write the t in terms of u and v, I will collect the t terms, okay, together. That is 32tu minus 8tv. I put it at the left hand side. And the term without the t, I will move to the right hand side. That is negative 16u squared at the right. So factor out the t, you got a 32. Okay, 32 u minus 8v, all right, equals to negative 16u squared. So in order to write the t in terms of u and v, I'm going to divide both sides by 32u minus 8v. I have negative 16u squared over 32u minus 8v. So we can actually simplify further and factor out the 8 from this denominator. We have this, and 16 and 8 can be simplified, cancel off. Finally, we have a negative 2u squared over 4u minus v. Sorry, this should be positive. This should be positive for u plus v because I have did some mistake over here. Negative multiplied by negative, that you will have a positive 8tv. So this is a positive, positive. And down here also has to be positive. Here means factor out the 8 still. Here will be positive. And finally, we have a negative 2u squared over 4u plus v. And this is the t as a subject in terms of u and the v. Proceed to the next example on this question. Given fx equals to 5x squared minus 3x minus 2, express fx in the form of this. This is the form that we want. This is in the form of completed the square. Meaning that we are doing the process of completing the square later on. To perform this, to write this this is not equation, this is a quadratic expression into this form, where A, H, and K are constant. Hence, find the values of x when the fx equals to 0. Alright, in short, means that this question asks us to use the method of completing the square to solve the equation of fx equals to 0. Alright, but it guided us to use this completing the square to perform this into this form first. So to do the completing the square, firstly, copy down the expression. Alright, this is your fx. And then to do completing the square, firstly, we must make sure that the coefficient of the x square must be 1, meaning that we need to factor out the 5. Cannot divide by 5, please, okay, because this is an expression, it's not an equation. So you cannot say divide 5 at both sides. There is no such thing. You have to factor out the 5. All right, factor out the 5, you have a x squared inside the bracket, and then 3 over 5x minus 2 over 5. After that, the completing square, the process will be done in the bracket. The 5 still will be outside. Alright, to do completing the square, I'm going to copy down the first two terms and then add the 2 bracket square minus bracket square minus the constant, constant, just copy down, that is a negative 2 over 5. Alright, I just remain back the 3 terms, copy down this term, and a constant term. In the middle, I just add in a bracket square minus bracket square. And now we have to decide what to fill in this bracket. We have to take the coefficient of the x, that is negative 3 over 5, negative 3 over 5, taking the coefficient of the x and then divided by 2. Negative 3 over 5 divided by 2, I got negative 3 over 10. So I'll put in the negative 3 over 10 into the bracket. So once now you can see that actually I'm adding a same value minus a same value, which is this will produce 0. Okay, so the quadratic expression, we did not change anything. We just trying to change the form, okay, by adding negative 3 over 10 square minus negative 3 over 10 square. After we have done this, we can factor the first 3 terms. The first 3 terms, it can be factored into the form of x minus 3 over 10 square. Alright, if you are not believe, you can actually expand this back, expand the square. You will get back the 3 terms, the first 3 terms here. After that, simplify, okay, simplify the constant. Square, okay, square of a negative 3 over 10, I got a 9 over 100. So now we can simplify the constant. We have a negative 49 over 100. Okay, so you multiply 5 in, so now you have completed your completing the square. Okay, so multiply the 5 inside, you have a 5. Multiply by x minus 3 over 10 square, and then 49 over 20. All right. Then we compare to the statement that is given by the question. There is over here a x minus h square minus k. You can see that the a is actually equals to 5, and the h will be in at 3 over 10, and the k is 49 over 20. All right, so now we move to the next question. That is hence find the values of x when the fx equals to 0. So this is our fx. All right, this is our fx. So when the fx equals to 0, you can write the equation like this. We're going to solve for the x now. So we will add 49 over 20 at both sides. Alright, so the left hand side will be like this, and it's as if that the 49 over 20, you move to the right hand side, you get a 49 over 20 at the right. And now divide both sides by 5, you have 49 over 100 now. Okay, so x minus 3 over 10 will be positive negative 7 over 10. After you have a square root, taking the square root of 49, that is 7. Okay, and then 100, square root of 100 will be 10. Then your x has to be positive negative 7 over 10 plus 3 over 10. This means that you got the two solutions. The first solution is 7 over 10 plus 3 over 10. That will be 10 over 10 x equals to 1. Or you may have another solution that is taking the negative 7 over 10 plus 3 over 10. That will be a negative 4 over 10. Simplify. You got a negative 2 over 5. So these are the solution when the f(x) equals to 0. Here is another example. It's going to use a discriminant to solve this problem. Given that the equation, this is a quadratic equation in terms of h, has an equal root, meaning that we can conclude that the b squared minus 4ac equals to 0, yeah? Because the question said that this equation has equal root, find the values of h. So now start with the, we have a x squared plus a h minus 4x plus h minus 4 equals to 0, where the a, b, and the c can be extracted from here. The a will be 1, and the b is a coefficient of the x, that is h minus 4, and the c is a constant, that is a h minus 4. So start from the b squared minus 4ac equals to 0. Put in your b squared as a h minus 4 square minus 4a. A will be your 1 and c is a h minus 4. It is equals to 0. And now trying to expand and simplify. Here I have a h squared minus 8 minus 4. That will be negative 12h and plus 32. Factorize this quadratic equation. We have a h 8 4, okay, and then negative negative. All right, so the h will be equals to 8 or the h will be equals to 4. So, and when the h equals to 8 or h equals to 4, your b squared minus 4ac is always equals to 0. This means that this equation always has an equal root when the h equals to 8 and 4. All right, then after that, so the equation just asks us to find the values of h without asking us to solve the equation. We can stop our solution here. That is finding the h value only. Okay, this is the last example in this video. We're going to prove that the equation, this is already in the general form, is a quadratic equation in terms of q, and we need to prove that this equation has only real root. Has only real root meaning that we are going to prove the b squared minus 4ac is greater or equals to 0, because the real root, we got the two cases. Okay, when the one quadratic equation has a real root, okay, there are two cases. That is the b squared minus 4ac greater than 0, meaning that we have the equation has two different real roots. If your b squared minus 4ac is equals to 0, meaning that you have a one real root. All right, so combine these two cases, then you will have a real root, meaning that now I'm going to prove that this equation, okay, is a discriminant b squared minus 4ac is going to be greater or equals to 0. Okay, so as I stressed before, now the question asks us to prove, meaning that at first we must pretend that we do not know. We have to start from the b squared minus 4ac. All right, so extract out the a, b, and the c. The a is a coefficient of the x squared, and the b is a 4q plus 3, that is the coefficient of x, and the c is a constant, that is q plus 1. So start from the b squared minus 4ac without knowing anything, just substitute the b squared minus 4ac into it. All right, so your b will be 4q plus 3 square minus 4a, a will be 4q plus 2, c will be q plus 1. And now we're going to simplify, expand and simplify it. After I have expanded this, I got this. So now you can see that the two terms the term of a 16q square and the negative 16q square cancelling each other, and a 24q minus 24q also will be disappeared. So now we left a 9 minus 8, that is equals to 1. So the 1 here, you can say that this is a greater than 0. Okay, so greater than 0 means that now you can say that, okay, since the b square minus 4ac is greater than 0, okay, we can say that the equation has only real root. All right, or precisely you can say has only different real root. Okay, has a real root also, because I just answering the question. The question asked me to prove has only real root, so I just follow the question, answering the question. All right, thank you for watching. In my next video, I'm going to discuss on the equation involving the cubic equation. All right.